S1 January 2008 question 5. Normal distribution. We'll start by sketching a diagram. Show the information provided. So ball bearings are accepted if they pass through a gauge of 1.070. So I have 1.070. I'm going to have my mean, and if they pass through this gauge, larger ones rejected are 3.5%. Remember, normal distribution always works with the larger area, so if that's 3.5%, then it's actually the 96.5% here that will be in my table. So I'm looking for an area, or phi of z, of 0.965. I need to work out from my tables the z value. So looking at the normal distribution tables, 0.965 doesn't appear, but 1.81 is 0.9649. So I need to add 1 to that. So I'm going to use 1.811. Using my formula, the z value equals the x value. Take away the mean and divide it by the standard deviation. I have one formula. Taking the information about balls that are rejected if they're too small, which happens at 0.960 and 1.5%. Again, we work with the larger area, so I'm interested in 98.5%. Going to my normal tables, I'm going to look for an area of 0.985. And we can see in the tables that 0.985 occurs at exactly 2.17. So the z value is 2.17, and because it's to the left of the mean, I need to show a negative. And that has to equal the x value minus the mean divided by the standard deviation. So now I have two formulas. To solve them, I'm going to have to multiply both by the standard deviation. So minus 2.17 standard deviation equals 0.960 minus the mean. And 1.811 times the standard deviation equals 1.070 minus the mean. So I have two equations and two unknowns, and to solve these I'm going to subtract them. Minus 3.981 sigma has to equal minus 0.11, so the standard deviation is that value divided by the 3.981, which gives us a standard deviation of 110 over 3981, which is 0.0276 0.0276 to three significant figures. Substituting that back into either equation, I get a mean of 1.10199, which again to three significant figures is 1.02. Finally, we're asked to work out the percentage of ball bearings with a diameter of greater than 1 centimetre. So I'm looking for the shaded area. First thing I need to do is work out my z value. And my z value is my x minus my mean divided by my standard deviation, and that gives me a z value of negative 0.6876. So that's negative 0.688 to three significant figures. Going to the normal distribution tables, 0.68 is 0.7517, and we have to add 26. So my phi of z is 0.7517, add 26, which gives me 0.7543. So there's 75.43% are greater than 1 centimetre. If we go to the same mark scheme for this part of the question and I look at the answer, it appears at first as if I have got the wrong answer, But we go up here to the top. To work out their z value, say I've done 1 minus 1.01996 all over 0.02763. Now you'll see I use 0.02763, which is 4 significant figures. The top they've used 6 significant figures, I've only used 4 significant figures. Whenever you use their z value, you get 0.7224, but when you use only 4 significant figures, you get 0.6876, which I rounded to 0.688. If you want an answer to 3 significant figures to be accurate, then the minimum you must work to is 4 significant figures. In this case, my answer I've used is correct.